In motor vehicles, an oil pressure sensor is a critical part of the engine. As oil lubricates, cools, and cleans the motor, this sensor constantly measures the pressure and signals a problem before it causes serious damage to the engine. Screwed to the engine block and connected to the car's computer, the sensor can detect the smallest change in oil pressure. The computer relays the information to the gauge on the dashboard. It allows the driver to tell at a glance if there's a pressure problem under the hood. To manufacture motor oil sensors, a robot picks up a perforated ceramic board and transfers it to a carriage. The carriage shuttles the board into a screen printing machine. It squeegees palladium silver paste onto it, creating a pattern for a sensor around each of the holes. The silver will serve as an electrical conductor. A trip through a long oven bakes the silver paste onto the ceramic. Then it's back to the screen printing machine. This time, the squeegee applies a green glass glaze onto the silver. The pattern leaves some of the silver exposed for the attachment of components like capacitors and diodes. A robot then applies those components faster than you can blink an eye. The next robot transfers terminals to the sensors. To align the prongs of the terminal with exposed silver on the sensor, the robot takes a picture and sends it to the computer. The computer then guides the positioning. It all happens in a flash. Once the terminal has been soldered to the sensor, another robot dispenses adhesive around the components. This seals the circuitry from the oil that will flow through the center hole. The next robot places a silicon chip on the sensor, covering and sealing the center hole. This chip will react to changes in oil pressure. Another robot bonds the silicon chip to the circuitry using aluminum wire that's thinner than a human hair. This completes the electrical connection. An employee now inserts the ends of the sensors in a fixture and breaks them along score lines. This separates them into strips of 5. She transfers the strip to a machine that bends the terminals to a precise shape. She snaps the ceramic along more score lines to separate the strips of 5 into single sensors. Next, she connects the terminals to posts and plastic housing. After soldering them in place, she folds the rest of the sensor over them. She then places brass shells in a carrier. She inserts 2 rubber O-rings in the shells, a large one and a smaller one around the center hole. The robots take it from here. The first one picks up the sensor assembly and, using a camera as a guide, transfers it to the brass shell. Then it's over to a press and crimp station. The top tool applies pressure to compress the O-rings, as forming tools crimp the shell around the sensor. An applicator coats the threads of the brass shell with sealant. When dry, this sealant will enhance the sensor's fit to the engine to prevent oil leakage. A test head probes each sensor, performing a full electrical evaluation. It also applies air pressure to test for leaks. After passing the test, the oil sensor is complete.